So we talked about solving systems by graphing, then we talked about solving systems by substitution when one of the equations is set equal to one of the variables. Now, solving systems by elimination is kind of user-friendly. So we use solving systems by elimination when both equations are set into standard form and graphing is not so easily done because the y-intercept is not an integer. So here's how it works. The idea is when they're both in standard form, okay, I'm going to go over 3 different types of questions that you could see. You first want to make sure that they're aligned. And what I mean by that is the x's are lined up, the y's are lined up, the equal signs are lined up, and the constants are lined up. If that's the case, then you move on to step 2, which means you decide, well, which variable do we want to eliminate? And we can only eliminate when the variables are opposites. So if you look at number 1, there are opposites right here on the x's. We have positive 4x and negative 4x. And so then all we have to do is add the equations. So think of it like one big addition problem. So if I look at my x's, I have 4x plus negative 4x, which ends up being 0, so they cancel. And then I have 9y plus 7y, which is 16y. And then 5 plus 11 is 16. And then all we do is solve for y. So all we have to do here is divide by 16. So y equals 1. Now, just like the substitution, we want to substitute my y value that we got into one of the original equations to see what that x value would be. So it does not matter which equation I do choose. If I choose the first one, I have 4x plus 9 times 1 equals 5. And then just distribute and solve. So 4x plus 9 equals 5, where I would subtract 9. And 4x equals 5 minus 9, which is negative 4. Then I would divide by 4, so x equals negative 1. So now my ordered pair, given the x and the y, would be negative 1, 1, my x and my y. So that's elimination. So if you look at number 2, again, you want to make sure the equations are stacked up and aligned. So 10x, your x's, your y's, the equal sign, the constants. Once that's the case, then you check to see if any of the variables are opposites. So here, my opposites are negative 3y and positive 3y. So I can move on to my addition problem. So 10x plus negative 2x is 8x. Negative 3y plus 3y ends up canceling, equals 18 plus 6 is 24. So then I solve for x in this problem. So I'm going to divide by 8, so x equals 3. Now, to find the y value, I take x equals 3 and I'm going to substitute it into one of the original equations. Again, it does not matter which one. I'm just going to go with the first one because it's there. So if I do substitute x with 3, I have 10 times 3 minus 3y equals 18. Then I have 30 minus 3y equals 18, where I'm going to subtract 30. And I have negative 3y equals negative 12. Then I'm going to divide by negative 3. So my y value ends up being positive 4. So my ordered pair ends up being 3, 4. And there you go. So let's try one more where it's already stacked and nice and pretty. If I look at this one, this one's a special one, so I'm going to put a star by it. All right, the reason what makes it special, but let's go over the basics. First things first, my x's are aligned, my y's are aligned, my equal signs aligned, and my constants are aligned, so I can move on to my addition problem. But first, we got to make sure we can see some opposites. So here's where this one's special, because if you notice, 2 and negative 2 are opposites, and 1 and negative 1 are also opposites. So if I do my addition problem here, we have 2x plus negative 2x is 0x, my x's cancel. My y plus my negative y also cancels, so I have 0 left on the left side. And negative 10 plus 10 equals 0 also. Since both sides are set equal to 0, 0 does equal 0. That doesn't mean my answer is 0. My answer is infinite solutions, or can be written as all reals. Remember we talked about when we graphed, this is whenever your lines are the same exact line. So it would be the same equations, is truth be told. Okay, so there's a special one. Now, that's all well and good whenever the variables are stacked up, there's already some opposites, but we have to also check, there's going to be problems where when they are aligned, they're not exactly opposites yet. So if I look at number 4, my x's are aligned, my y's are aligned, my equal signs aligned, and my constants are aligned. When I go to look for opposites, positive 2 and positive 2 are not opposites. In order to make them opposites, I need to multiply one of the equations by a negative 1, okay? Which means ultimately just change all the signs in that equation. So it does not matter which one I choose. It really just comes down to choice. So if I choose the first one, positive 4x becomes negative 4x, 2y becomes negative 2y, and positive 6 becomes negative 6. Now I can do my addition problem because now I have opposite 2's. And negative 4x plus negative 2x is negative 6x. Negative 2y plus 2y is 0. That cancels. Equals negative 6 plus 18, which is positive 12. And then I solve for x. I'm going to divide by negative 6. So x equals negative 2. So there's my x value. Again, just like before, we're going to take my x value and substitute it back into one of the originals. It doesn't matter which one. But make sure honestly, make sure you go back to the original. So if I do choose the first one, I'm going to go ahead and just kind of forget that I changed all the signs. So I have 4 times negative 2 plus 2y equals 6. And then I have negative 6, or negative 8, sorry. Negative 8 plus 2y equals 6. I'm going to add 8 to both sides. So 2y equals 14. Then I'm going to divide by 2. So y equals 7. So my ordered pair ends up being negative 2, 7. So number 5, x's are aligned, my y's are aligned, my equal signs aligned, and my 14 and 15 are aligned. Then we check for opposites. So yes, I have 3x and 3x, but they're not opposites because they wouldn't cancel when I add them. So I'm just going to pick one of the equation and change all of the signs. I'm going to go ahead and just change it up and do the second equation. There's no rhyme or reason. It's just because I want to. So 3x becomes negative 3x, negative 9y becomes positive 9y, and 15 becomes negative 15. So then I add, because I did that, now my x's cancel, and negative 10 plus 9 is negative 1y, and 14 plus negative 15 is negative 1. When I divide by negative 1, be careful because that's the silent killer. Negative 1 divided by negative 1 is positive 1. Now I'm going to take that solution and substitute it back into one of the originals. Again, it doesn't matter which one you choose. If I do the first one, I have 3x minus 10 times 1 equals 14. Where 3x is minus 10 equals 14, I'm going to add 10. So 3x equals, if I add 10, that's 24. I divide by 3, so x equals 8. Oops, x equals 8. So my x and my y are there, so my quartered pair would be 8, 1. So number 6, like I showed you with substitution, I want to see how that can also apply to whenever they're already in slope-intercept form. Yes, I can solve both by graphing because they're easy to graph, but if I lack graph paper, then I want to show you how elimination will work here. Again, elimination works when everything's stacked. It doesn't necessarily mean it has to be in standard form. It can be in slope-intercept form as well. So my y's are aligned, my equal signs aligned, my x's are aligned, and my constants are aligned. So then we also want to look for opposites. So yes, it looks like my y's are there, but they're not opposites. Like y plus y does not cancel them out. So again, just change all the signs of one of them. If I choose the second one, y becomes negative y, x becomes negative x, and negative 2 becomes 2, positive 2. So now that my y's cancel, I have 0 here, equals 3 plus negative 1 is 2x, and 4 plus 2 is 6, so plus 6. I'm going to solve for x, so I'm going to subtract 6 to both sides. So negative 6 equals 2x. I'm going to divide by 2, so negative 3 equals x. There's my x value. And just like before, we're going to substitute that x in for one of the equations on the original. So if I do the first one, it's y equals 3 times negative 3 plus 4. 3 times negative 3 is negative 9 plus 4. So y equals negative 9 plus 4 is negative 5. So my x is negative 3, my y is negative 5, so my ordered pair is negative 3, negative 5. So the third and final type when it comes to elimination is what do I do whenever they're aligned, the variables are aligned, but there's no opposite integers. This is whenever you don't just change all the signs, you have to multiply by an integer to make them opposites. So here's an example, number 7. Obviously, at first, we check to make sure they're aligned. So x's, y's, equal sign constants, that's great. But then I go to look for it, and I don't see opposites. Like, I don't see 2's, I don't see 3's, I don't see 6's, I don't see, like, the stacking happening. So we have to figure out, okay, which variable do I want to eliminate and which route to go so that way it's less work for me. So if I look at it, if I want to eliminate my x's, that means I would have to make them both 2's. So to make them both 2's, I would have to multiply the first equation by 2. If I want to cancel my y's, that requires more work because in order for them to be opposites, I would have to multiply the first equation by 7 and the second equation by 3 to make them 21. So in that case, I'm going to go the easy route. And I want my x's to eliminate. So I'm going to multiply that first equation by 2. But not just 2, because I don't want the 2's just to stack up. I want the 2's to cancel. So in order to cancel a positive 2, I'm going to multiply by a negative 2. So let's change it. Negative 2 times x is negative 2x. Negative 2 times 3y is negative 6y. And negative 2 times 6 is negative 12. So now that I've gotten rid of that original equation, I have my variables still stacked up. I can now add. And now I can cancel my x's because 2x plus negative 2x is 0. Negative 7y plus negative 6y is negative 13y equals negative 1 plus negative 12 is negative 13, where then I divide by negative 13. So y equals positive 1. Then I'm going to substitute my y value in for one of my originals. This is where I can utilize my original equation that I might have changed. And I'm just going to choose that just because it's the first one. So if I rewrite it, x plus 3, where I substitute 1 in for y equals 6, I have x plus 3 equals 6, where all I have to do is subtract 3. So x equals 3. So my x value is 3, my y value is 1. There's my ordered pair. So let's try it again. If I look at number 8, I want to see which variable I want to cancel. Again, it doesn't matter which one. It just think about what one would make more sense and be quicker. So if I look at number 8, if I want to make my x's cancel, the only common multiple that they could have is 18. So I would have to multiply the first equation by 2 and the second equation by 9, and that would be both. Whereas on my y's, the only thing I would have to do for them to cancel, make 3 and 1 cancel, it would be to multiply the second equation by 3. But not just 3, negative 3. Because if I just multiply by 3, that's 3 plus 3, that doesn't cancel. I want to multiply by negative 3 so that my y's cancel. So now let's multiply. Negative 3 times 2x is negative 6x. Negative 3 times y is negative 3y. And negative 3 times 5 is negative 15. So then I've gotten rid of that, and now I can cancel by adding. 9x plus negative 6x is 3x. 3y minus 3y, my y's cancel. So I have 12 plus negative 15, which is negative 3. Now I can divide by 3, so x equals negative 1. There you go. So then I take my negative 1 and I'm going to substitute it back into one of the originals. If I choose to do the first original equation, it doesn't matter. I'm going to substitute x in for negative 1 with negative 1. So I have 9 times negative 1 plus 3y equals 12, where 9 times negative 1 is negative 9 plus 3y equals 12. I'm going to add 9. So I have 3y equals 21. I'm going to divide by 3. So y equals 7. So my x was negative 1. My y is 7. So my final ordered pair is negative 1, 7. Okay, taking that, let's practice some more. So number 9. What could I multiply by? So which one do you want to cancel technically? Yes, if I want to do the x's, I would have to, the least common multiple would be 15. So that means I would have to multiply the first one by 5, the second one by 3, and that's more work. It's not wrong, it's just more work. So I want to go the easy route. If I want to cancel my y's, the only thing I have to multiply is the first equation by 4. Now this time, I only have to multiply by 4 because it's negative y, so that will ultimately cancel my y's. So I don't want to multiply by negative 4 this time. So 4 times 3x is 12x. 4 times negative y is negative 4y equals 14 times 4, which is 56. And then now I have my y's that I can cancel, so I'm going to add. 5x plus 12x is 17x. My y's would cancel, and 12 plus 56 is 68. So then I can divide by 17 to both sides. So 68 divided by 17 is x equals 4. So x equals 4 is my value. I'm going to take that x equals 4 and substitute it back into one of the originals. So if I choose the first one, it would just be 3 times 4 minus y equals 14, where 3 times 4 is 12 minus y equals 14. I would subtract 12, so I have negative y equals 2, divide by negative 1, so y equals negative 2. So my ordered pair would finally be 4, negative 2 as my final answer. Just to practice some more, if I look at number 10 is pretty easy because I have options this time more than I did before. If I want to cancel my x's, I would have to multiply the first equation by negative 5. If I want to cancel my y's, I would have to multiply the first equation by 2. So both ways would be correct. It really just comes down to what you want to do. So let's say I just want to multiply the first equation by 2. I'm going to do 2 times x is 2x, 2 times y is positive 2y, and then 2 times negative 3 is negative 6. So then I can see where my 2's would cancel, or my y's would cancel. So 5x plus 2x is 7x, negative 2y plus 2y cancels, and negative 50 plus negative 6 is negative 56, where I would divide by 7 to solve for x. Negative 56 divided by 7 is negative 8. That's my x value. So I'm going to take my x value and substitute it back into one of the originals. Let's just say the first one. So negative 8 plus y equals negative 3, where I would add 8 to solve for y, so y equals 5. So my ordered pair ends up being negative 8, 5. Number 11. So number 11, you got to think about which one you would cancel. If I want to cancel the x's, the least common multiple would be 6, which means I would have to multiply the first equation by 2, the second equation by 3, whereas if I want to cancel my y's, the least common multiple for 3 and 1 would be 3. So I have to be careful though. If I multiply the second equation by 3, my y's wouldn't cancel because negative 3y plus negative 3y does not cancel. So I actually want to multiply by negative 3. Negative 3 times 2x is negative 6x. Negative 3 times negative y is positive 3y. And negative 3 times negative 15 is positive 15. So now I can have my y's cancel. 3x plus negative 6x is negative 3x. My y's would cancel. Equals negative 3 plus 15, which is 12. I would divide by negative 3, so x equals negative 4. Then I'm going to take that negative 4 and substitute it back into one of the original equations for x. Let's say I choose the first one. It would be 3 times negative 4 minus 3y equals negative 3. 3 times negative 4 is negative 12 minus 3y equals negative 3. So I would add 12 first. So I have negative 3y equals 9. Divide by negative 3. So y equals negative 3 as my y. Where my x was negative 4, so my final solution is negative 4, negative 3. Last but not least, number 12. If I want to, if I want to cancel my x's, the least common multiple of 3 and 7 would be 21, which means I would have to multiply the first equation by 7 and the second equation by 3. That's a lot more work than I want to do. The second thing I could do is cancel my y's. The least common multiple of 4 and 8 would be 8. So the only thing I would have to do is multiply this first equation by 2, but not just 2, because if I multiply by 2, then my 8's wouldn't cancel. I would have to multiply by negative 2. So negative 2 times 3x is negative 6x, negative 2 times 4y is negative 8y, and negative 2 times 6 is negative 12, where then I can cancel my y's now. 7x plus negative 6x is x, or 1x. My y's would cancel, and then 10 plus negative 12 is negative 2, where I would technically divide by 1, which is just negative 2. Now I'm going to substitute that negative 2 in for one of the x's of the original equation. It doesn't matter which one. If I do the first one, it would be 3 times negative 2 plus 4y equals 6. 3 times negative 2 is negative 6 plus 4y equals 6, where I would add 6. And 4y equals 6 plus 6, which is 12, divided by 4, so y would be 3. And since y is 3, my ordered pair would be -2, 3.